second.
the problem with that one
Mm-hmm.
is that it's not like that you have like two the opposite directions.
Yeah.
So I don't know if he wants to know at the moment of at the final velocity or at the initial one.
Question, are you serious?
Okay, so for that
I'm
one,
gonna try. No, not yet. Define the system, that is, what object
impulse
or
for
object should be
55.
inside the system. That
So
is
for that one, you guys
also
have a truck,
existing.
and it's going forward at
Momentum is
how many?
conserved.
It's going at
100.
6 meters per second.
60?
6.
6. Oh, not fast. Meters per second, and how
Our
much does it
system
weigh?
includes
The weight is
2,000 kilograms.
2,000 kilograms. So you have a before and
Yes,
after.
yes, yes,
It just
yes,
looks
yes,
like
yes.
this is your before and this is your after. It's going
Yeah.
4 meters per second.
This one right
Still
here.
same mass.
What is the racket's speed after it hits the
kilograms.
ball?
Mm-hmm.
So you're
We're
gonna
gonna
use
get
your
to that
momentum
point.
equation
Okay.
to solve for this.
So I use the one
So
that
we're defining
yeah,
a system
momentum.
that is the object.
so initial
or
momentum is gonna be
object
that
should
mass
inside
times the
system.
velocity, right?
Mm-hmm. And normally if momentum is conserved, for momentum to be conserved, it's mass times velocity is equal to mass times velocity. You only have one because there's only one object. But you know for a fact that that times that is not going to be equal to that times that.
Right.
So you have to take into account the impulse. Then that's where this comes in. It's plus your J. I think that's what it is. J is impulse?
Yeah.
J? Yeah? We'll just call it J. So J is impulse. Now you're solving for this. Because this is what that's what it's asking for, the magnitude of the impulse that's being felt. So here you have mass of the car, velocity initial, velocity set, final.
That's how you do it.
And so then what you do is you just subtract that to that
Like,
side.
shouldn't it be like the opposite though?
Well,
Like m times v final is equal to m times v initial.
because you want these to be equal. This is going to be 0, 0, 0 kilogram meter per second. And this is going to be 8,000
Yeah, that's what
kilogram
I
meter per
get.
second. So then for this to be equal to that, you have to have your impulse on this side. You can make it like this with a negative J. That's correct. If you make that a negative J, then you're saying that that minus something is equal to 8,000.
So plus j.
Or you can say 2,000 is equal to 8,000 plus your impulse.
So you're gonna say that that's the same as saying the initial. So initial momentum, it's equal to the final momentum plus the impulse.
Yeah. That impulse is how much momentum you lost.
So in
Is
this
it guys
case,
good
it's
drawing
gonna
there?
be
Hmm?
Right drawing there.
Get my coordinate systems down.
it's gonna be 4 kilonewtons per second.
Cool.